Hi, my name is Victoria Calvin, and I'm a senior anthropology major at the University of South Alabama.
And I'm Jeremy Simmons, and I am a senior anthropology major at the College of William and Mary. In summer 2019, we participated in a research experiences for undergraduates program, or REU, at the University of South Alabama.
As part of this program, we conducted research on archaeological human remains from two tombs known as an-Nar and an-Nar, which are today located in the Emirate of Ras Al Khaimah in the United Arab Emirates. The bones inside these tombs were found to be mostly commingled, which means that instead of individual skeletons, the bones were completely mixed up.
These tombs are from the an-Nar period, which dates back to 2700 to 2000 BCE, part of the early Bronze Age in southeastern Arabia. Settlements appeared during this time along with newly developed method of agriculture called oasis agriculture to sustain a more sedentary lifestyle.
We were interested in learning more about the people in the an-Nar period and how they interred their dead through examining the commingled human skeletal remains found in tombs an-Nar and an-Nar.
Our research project focused on estimating sex, or the number of males and females in each tomb, using the temporal bone of the skull. The temporal bone is located on either side of the skull and contains the ear canal.
To begin our research, we first developed hypotheses, or educated guesses, about who was allowed to be placed in these tombs. Our first hypothesis was that there would be no difference in the ratio of males to females between tombs an-Nar and an-Nar. While the development of social hierarchies during this period might affect the sex ratios found in these tombs, we predicted that the number of females and males would be relatively equal based on previously reported sex ratios from other nearby an-Nar tombs.
To test this hypothesis, we first used a feature called the mastoid process of the temporal bone. The mastoid is a projection of bone behind the ear and is generally larger in males and smaller in females. To estimate sex more scientifically, we assigned a score between 1 and 5 to the mastoid process based on its size.
In addition to using the mastoid process, a second feature was evaluated, referred to as the lateral angle of the internal auditory meatus. This is a canal that transports nerves and vessels into the inner ear. Males generally have a smaller angle to this canal, while females exhibit a larger angle. To measure this angle, we created a mold of the inner ear canal using dental casting materials. After the mold hardened, we removed it from the canal and cut it in half using a scalpel. The two halves of the mold were then scanned and printed on paper so that the angle of the canal could be measured. The results of sex estimation using the lateral angle and the mastoid process were then compared to see whether these two techniques agreed with one another.
Our second hypothesis dealt with how cremation practices might affect our estimates of sex. Since high temperatures from cremation can also cause bone to shrink and change shape, this could have an effect on our observations of the mastoid process and the lateral angle. Because of this, we hypothesized that there would be a higher rate of agreement between our two methods of sex estimation on uncremated remains than with cremated bones. When bone is directly exposed to different levels of heat, its color begins to change. Unburned bone is a light brown color, but with increasing heat turns dark brown, then black, gray, and finally white. To determine how burned our bones were, we used Munsell soil color charts, a tool used by archaeologists which provides a universal standard to define colors. Bones were assigned a color category ranging from 1, which represented unburned bone, to 6, which represented the highest burning temperatures.
Our data was collected using only temporal bones that had both the mastoid process and the internal auditory meatus. We found that based on the mastoid score, tomb an-Nar showed that the male to female ratio was 15% male and 65% female, with 20% non-identifiable. On the other hand, an-Nar yielded ratios of 16% male and 70% female, with 14% not identifiable.
These results show that there is not a lot of difference between each of the tombs in terms of who was allowed to be placed there after death. Relative to other tombs in the area, however, an-Nar and an-Nar had a much larger number of females present, meaning there is a possibility of gender stratification occurring during this time period. Alternatively, it may mean that the mastoid process is not a good feature to use for sex estimation in these particular skeletons, as the mastoid process may be smaller for the population as a whole and not just in females. When comparing the lateral angle to the mastoid, we discovered that they did not match well. The lateral angle technique found a ratio closer to 50-50 for males and females, an equal ratio commonly reported in other nearby tombs during this time period. This may suggest that the lateral angle is a better way to estimate sex for people from this region and time period.
Finally, when comparing color changes to bone, we did not find a big difference in the number of males and females identified between cremated and uncremated bones. Therefore, cremation practices did not seem to have an effect on our sex estimation results.
To conclude, more research on sex estimation using other features on these skeletons is warranted to continue assessing who was allowed to be interred within tombs during the an-Nar period and why.
Jeremy and I would like to give a special thanks to the National Science Foundation for funding this research, the government of Ras Al Khaimah, Department of Antiquities and Museums for permission of studying the remains, our project mentors, Dr. Amelia Hubbard and Dr. Alexis Boutan, and our directors of the REU, Dr. Leslie Gregorica and Dr. Jamie Ulinger, for the excellent leadership throughout the entire research process.